Okay, let's see. This week we will talk about descriptive analytics and what we have to do with raw data. Your assignment this week will include raw data that you will have to clean before analyzing. Descriptive analytics is a preliminary stage of data processing that creates a summary of historical data to yield useful information and possibly prepare the data for further analysis. The nature of data. Data are facts and statistics collected together for reference or analysis. Data can come from many sources, including surveys, scraping data from the internet, the results of designed experiments. Data can be on any topic, from the number of fish collected from the St. Johns River to the temperature recorded daily, or things like financial data that is used to make a decision if you are to get a loan or not. Data can be quantitative or qualitative. Quantitative data uses numbers that represent real values. However, qualitative data can use numbers too, such as ordinal data on a survey, where you select how much you agree or disagree by picking 1 through 5. The numbers here do not actually represent quantities, but rather a degree of opinion. Binary data can be the same, where we code 0 for no and 1 for yes. Other kinds of qualitative data can be categorical, where we use words, images, or colors to describe a particular data point. Data, in and of itself, is meaningless, but when we add meaning to that data, it becomes information. To perform any useful analysis on our data, we must have quality data. You will hear the saying, garbage in, garbage out. If we do not start with good data, we will not get good or valid results. We can break data down into structured and unstructured data. Structured data is the typical data you have seen, where nominal data is when we use numbers, but they have no real quantitative meaning, whereas ordinal means the numbers we use have order but no quantitative value. Ratio and interval data are actually numbers that mean something, like the square footage of house or the price of the house. Unstructured data is data that we cannot easily put into columns, like textual data such as online reviews. It is hard to draw meaning from an online review, but if you had 1 million online reviews, how would you be able to analyze that data? It's a special kind of analytics called text analytics that we'll talk about later. Multimedia data can be audio or video, such as face or voice recognition, and a lot of machine learning is focused on the use of this kind of unstructured data. And big data has a lot to do with unstructured data as well. In the real world, data is raw and dirty. In classes, you're generally given data sets that are already set up to do analysis on, but when you get a real job, you have to query for your own data and then pre-process or clean it before you can start any real analysis. There are several steps in that process we may need to take in order to get the data ready, including consolidating, cleaning, transforming, and reducing. This is a skill that will take time to develop, but it just takes practice. So, the first thing we will do with a new data set is look at the variables to try to get an idea of what we might want to use to do with analysis with. One common problem is lines of data that are missing values for variables. We can deal with this a number of ways. One way is just to remove incomplete rows. If you distributed a survey and some people did not fill out all the questions, you may have to throw out the surveys that are incomplete. This only works if you have an adequate sample size, though. For regression, you will need 20 samples per variable. So if your survey had 5 questions, you would need at least 100 responses to get good analysis. But what if throwing out surveys drops you below the sample size requirement? Well, then you may want to look at imputation. Imputation is where we insert the average of that column of data where there is missing data. Another way is to fill in the data with a random number from the column. I would never actually do that, but it is a possibility. The last option is called linear interpolation, which involves the average of the data above and below the row data with the missing value. After we have data with no missing values, we need to select the set of variables that will be most useful to our analysis. We will learn more scientific ways of variable selection later in the semester, but for your assignment now, just pick ones you think will try to fit the intended results. So we have some data here. It's just randomly generated data. These two columns here are actually columns in your homework assignment. So the output variable or response variable or your dependent variable is whether a particular loan was fully paid or it was charged off. Or fully paid means they actually paid the loan, or charged off means it was defaulted and you charged or wrote it off. These are variable 5 is 36 months or 60 months. That's how long the loan length was. And then there's 4 columns of randomly generated data. But what you'll notice is they're not full. So we only have 20 rows of data. So we could only select one variable if we were doing regression. The other problem is there's all these NA variables, which means we have missing data. So one option is we can insert the average for this column of data. So the average is actually down here. I've already generated it. So if we just do equals average, should be 55.79. So we can replace that value with 55.79. Now we have no missing data in that column. That is just a very simplified version of how we might have to clean data. And that would be called imputation, where we put the average in for that column of data. So now let's say you are an analyst sitting at a computer and you get an email from your manager, a problem that needs an answer, such as this month's employee satisfaction. Well, all the data for the company is stored in a database or data warehouse. We do not need all the data to solve this problem, so we must consolidate the data to what we actually need. Thus, this is called data consolidation. It can involve using SQL to query the data warehouse or database and pull in only the data that you're interested in. The next step is data cleaning, which is what we just talked about, but to remove missing values, but sometimes we also may need to remove outliers that would skew our results, such as from a disgruntled employee that put all ones on his employee satisfaction survey. This also could be considered erroneous data, and we would want to remove it in our data cleaning process. The next step is called normalization or scaling. We want to get all the variables on the same relative scale so as not to skew the analysis. We also may find the data is not from a normal distribution, and thus we will have to transform the data with something like a log transform. So I have our data cleaned up to that point. We may find that other times we have to combine different variables into new attributes. Let's say we wanted to create a new variable column that multiplied or divided out the square footage by the selling price of the house so that we get the average cost per square foot. Say we're looking at a particular region of houses. With data reduction, Principal component analysis is more of an advanced concept that you probably would not learn until graduate school. But something like random sampling is something you might use if you were looking for experimental results or an experiment. So now that our data is pre-processed, we will want to check a few other things, such as measures of central tendency or dispersion. So we want to summarize our data with descriptive statistics like mean, median, and mode, or variance and standard deviation. So let's take a look at some data. Here we have two two columns of data, two classes with final exam scores. And this is their scores. We also have some bin values for us to set up a histogram. So first thing we can do is find our summary statistics. Now to find mean, we can do the average of that column of data, and that will give us the mean. We can find the median. So our median volume is 84. We can grab the handle here and get over and find that the median volume for class B is 77. For mode, to this one, same idea. So the mode for class A, which is the most common value, is 75. And we can drag this over and get a result for class B. We can also find the first and third quartile. And then we use comma 1, and it will give us our first quartile. And if we do comma 3, we can get our third quartile. We can find our maximum value in the range. And our minimum value in the range. As well as our kurtosis. And our skew. And finally, our dispersion statistics by looking at the variance and the standard deviation. So those are the different functions in Excel to find the different summary statistics. However, you could also do something in data analysis where we can go just to descriptive statistics and grab the data. Output range. that will give us our summary statistics for our two classes, Class A and Class B. And that's kind of the easy way to do it, but I wanted to show you the different functions used to get the same data. Next step is we'll want to do data visualizations for our descriptive statistics. And that would include our histogram, box and whisker plot, and possibly a scatter diagram if we're looking at the linear relation. Okay, so to do a histogram, it's also in the data analysis tab. We'll grab our set of data and our bin values. And let's put it there. That tells us what bins and put chart output. There we go. There. So now we can see our histogram, how the data is distributed. We can do the same thing for our other class. So now we can look at the histograms for the two different classes and see visually our summary statistics. You can see that the average is higher in Class A than Class B. Also, look at box and whisker charts. So let's see. Go to box and whisker. Copy that. So for Class A, what the box and whisker chart looks like. That's what Class B looks like. So we can compare those and see that average is lower in Class B, but the spread is higher, or the range of values is higher. Okay, and then a scattergram. Let's say we have some data, some time series data. We have hourly data, or hourly of the number of ED patients in the emergency department. So what we want to create is a scatter diagram. Just look at this for a day. So this tells us or shows us the flow of patients into the emergency department. And if you're trying to put the entire month's worth of data, it would be too busy. But what we can tell is that somewhere around 6 o'clock in the morning has the fewest number of ED patients, and around 5 o'clock in the afternoon, or I guess that's 2 o'clock in the afternoon, we see a peak in the number of ED patients. So the last thing, now that we've done our descriptive statistics, we want to set up some analysis. So I have some data on Visa stock and its weekly change, as well as the change in the S&P 500 index weekly change. I want to set up a model to see how much change is reflected in Visa and the S&P 500. So we're going to go back to our data tab and data analysis. So now we're going to look at regression. We're going to want to put our results there. All right. So this creates our regression output. Most important parts of our regression output are going to be our R squared, which tells us how much variance in Y is explained by our variable X. So it's about 68%. We also wanted to look at our F statistic, but particularly our p-value for our F statistic, because that tells us how, if we should even be looking at this model in the first place. So it should be less than 0.05, but this is very significant at a very small number. So that's good. Then we want to look at our coefficient. And what this represents is for every 0.70 change in Visa, we'll see a 1 point increase in the overall index of the S&P 500. So would Visa be a good buy relative to the S&P 500? In this case, it would be better to buy the entire index, like using the Spider Fund, because its increase is better than the increase in the stock alone. So that gives you an explanation on the last tab here. Okay, so that is descriptive analytics, and we'll talk about more regression later in the future.